Soviet Union, the early 1960s. The Cold War with the United States was never more intense. Two great world powers engaged in a battle for supremacy, a battle fought on land, on sea, and in space. And nowhere was the competition more fierce than in the race to the moon. It was a contest the Americans would eventually win. But the Soviets, it turns out, had one spectacular success. A success nearly forgotten by history until now. It was a time full of optimism in the USSR. The great socialist experiment begun by Vladimir Lenin more than 40 years earlier seemed on the verge of triumph. The Soviets were determined to defeat the West, and they had taken the Cold War into space. The first satellite was called Sputnik. The first man to orbit the Earth was named Yuri Gagarin. A cosmonaut, Alexei Leonov, made the first spacewalk. And the Soviets' big plans didn't end there. Like the Americans, their sights were set on the moon. But they wanted to do more than just take a walk on the surface. The Soviets dreamt of building a permanent outpost.
I would say that most people, not just in the United States, but in the world, don't know of the Russian accomplishments on the moon.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
But not only NASA took up the president's challenge. Soviet Premier Nikita Khrushchev wanted the moon for the USSR. He turned to his most accomplished rocket designer, Sergei Korolev, the father of the Sputnik program and the engineer behind the launch of Soviet intercontinental missiles. Korolev had ambitious goals. First, he wanted an unmanned rocket to orbit the moon, then another to reach the surface. Finally, he came up with an idea way ahead of its time, one that wouldn't be tried again for nearly 3 decades. He wanted to send to the moon an automated vehicle, a remote-controlled car operated from Earth. For the Soviets, a lunar car was only the first step toward an audacious dream to build a permanent base on the moon. The lunar rover would be called Lunokhod, or Moonwalker. To build it, Korolev would need to find the best and the brightest. And in the USSR in the 1960s, that brain trust could only be found in one place: the Red Army. In Leningrad, the Transmash plant built assault tanks. The factory had everything Korolev needed: space, high-tech machine tools, and the best minds in the country. The first job was to design the chassis for the Lunokhod. Working with what was then cutting-edge electronics and computers, engineers toiled in secret. Among them, one man would soon rise and become the heart and soul of the program: Alexander Kamerjian.
My father was a tank designer by profession, and he first worked at Transmash as a specialist in heavy-tracked vehicles. He was later appointed Director of Research and Design for air cushion crafts. He began to acquire a reputation as someone who could conceive of and create the most unbelievable devices.
For Alexander Kamerjian, designing the Lunokhod was an amazing opportunity for incredible success or humiliating failure. The technical challenges were many. Could a remote-controlled vehicle be operated from some 250,000 miles away? How would the moon rover react in an environment with just 1/6 the Earth's gravity? Computer technology was in its infancy. Simulations were out of the question. building the Lunahod was truly on the edge of what was possible.
Major achievements of the Lunacode program were, one, that it was extremely early, two, that it did generate some meaningful science, three, that it represented the solution of some difficult engineering and design problems by some very smart people.
This project would rely on robotics, a field that in 1963 was more science fiction than science. More difficult still, every component had to be conceptualized, invented, then tested. Engineers first built prototypes, scale models. Designers were often the only ones who saw their wheels turn, or to see them take their first steps.
We were put in a room closed off from prying eyes. This is where we set up our drawing boards. Access to our offices was forbidden. At the time, our work was classified as a military secret.
There was never any talk about the Lunahod at home. I only learned that my father had worked on the chassis for the lunar vehicle and that he was one of its designers after the device had reached the moon.
In the mid-1960s, while the Soviets toiled in secret, the American space program was literally taking off. The success of Mercury and Gemini set the stage for Apollo, the most ambitious exploration program ever attempted.
What a beautiful view.
Space was a geopolitical battleground, and President Kennedy and Premier Khrushchev put intense pressure on their engineers.
Американцам Луну не отдадим.
We couldn't let the Americans have the moon.
Тогда же с Америкой уже были отношения.
It was the Cold War.
Конечно, холодная эта война.
But fighting for the moon created very down-to-earth problems. For one, nobody knew what the moon's surface was made of. Was it stable? What if the rover disappeared into quicksand? Sergei Korolev consulted top Soviet geologists. Their best models predicted solid ground.
It was not possible to design a remote-controlled lunar vehicle able to travel over a terrain of dust, sand, and rock. We had to find a single option and make a decision.
Once this decision was made, we started thinking about the first prototypes. And later, when we saw samples of the lunar surface, we knew that Korolev's decision was correct.
With the question of the lunar surface hopefully put to rest, the team began to consider the mechanics. One major point of contention: would the rover have tracks or wheels? The engineers turned to Korolev.
Korolev told us, "I won't give you any advice. You're the specialists. You figure it out."
Alex Kamergian and his team were tank designers, so initially they favored a track drive mechanism.
I quickly understood that it would be extremely difficult to use tracks because the electrical energy required to operate the motors was only around 300 watts. Can you imagine? It's the energy of a light bulb. It's very, very weak. The energy of a light bulb was supposed to power the Lunahod under the extreme conditions on the moon.
The rover would be powered by solar energy, a huge challenge. Key to success meant building a lightweight and efficient drive mechanism. Plus, engineers needed to design wheels able to grip the lunar surface. They tested a tread of wire mesh fitted with crampons. But these details were just